Good day, grade 12 learners. Welcome to today's subject, which is technical science lesson. My name is Mashoud Mambur. This lesson is brought to you by Gauteng Department of Education in collaboration with Saipono Discovery Center, and is broadcasted by Pakama Research and Development. I'm looking forward to a good day. Our WhatsApp number is 060-667-5044. I repeat, 060-667-5044. All your questions, ask them. We are looking forward to a nice lesson. Let's enjoy ourselves. So as we had our lesson last week, we continue on today the topic is activities on organic molecules, naming and structures. So we'll be doing more activities as we move on. Remember, our learners, we said we have the 9 homologous series that we are doing, which we said is AAA, Hig, AC. So that you don't forget at all these 9 homologous series. We said the first 3 is alkanes, alkenes, and alkynes. We said those 3 are called hydrocarbons. They are hydrocarbons because they are made up of hydrogens and carbons only. And these alkanes, alkenes, and alkynes, we talked about their general formulas. We said the general formula for alkanes is CnH2n plus 2. CnH2n plus 2. You will remember, learners, we said for you to get the general formula for alkenes, you will have to get rid of 2 hydrogens, which means for alkenes, the general formula will be CnH2n. So you have to understand that to move from alkenes to alkynes, we remove further 2 hydrogens. Then you were able to get CnH2n minus 2. So I hope you still remember these general formulas that we have done. And we are saying all the time, no, we are starting with the alkanes. Then we remove 2 hydrogens, we get alkenes. We remove 2 hydrogens, we get alkynes. So those are the 3 hydrocarbons that we dealt with. Now, as we move forward, we go to what is called haloalkanes. Haloalkanes, we are simply replacing 1 hydrogen with a chlorine or a bromine for our grade 12 context. So in grade 12 technical science, we'll be using the bromo and the chloro, the 2 halides, the two group 17 elements, which is your chlorine and your bromine. So what am I saying? I'm saying for haloalkanes, we are going to have only 2. So what we have, the general formula will be the same, CnH2n plus 1x. Then you will remember that the x is replacing 1 hydrogen. So you have to know that, okay, the only difference between alkane and haloalkane is that we are substituting or we are replacing 1 hydrogen with a halogen. So we are able now to get what we refer to as haloalkane because we replaced only 1 hydrogen from the alkane. Then the general formula will be CnH2n plus 1x. So what we will have there, when we are dealing with that, we can have a structure. For example, if I draw a simple structural formula, it will be like that one, which will refer to it as bromomethane. So that will be bromomethane because we're having bromine there. So you have to know the haloalkanes, that we are replacing a hydrogen with a bromine. We can even replace 2 hydrogens, then it will be dibromomethane. So depending on the number of halogens that we are replacing with, it will be able to get us the structure. So we are moving now away from hydrocarbons. We are going to haloalkanes. So I have indicated to you that haloalkanes, we are simply going to the general formula of alkanes, which is CnH2n plus 2. We replace 1 hydrogen. Then the general formula for haloalkanes, it will be CnH2n plus 1x. I hope we have understood ourselves. You will remember what we said. We are saying that for hydrocarbons, for alkanes, alkenes, and alkynes, we are saying that we have meth. If we have 1 carbon, we said it's a meth. 2 carbons is eth. 3 carbons is prop. 4 carbons is but. 5 carbons is pent, and 6 carbon is hex. You will remember that. So that we said always you look at the number of carbons to say how many carbons do we have in the parent chain. Then if you have 1, the prefix or the name will start with a meth. Then if it's 2 carbons, eth. However, when we move now to our aldehyde, ketones, esters, alcohol, and carboxylic acid, we don't write the meth, we write methane. You write the entire name, you only remove the E at the end of the name. So you have to know, for example, if it's an alcohol, it will be methanol. If it's a carboxylic acid, it will be ethanoic acid. So don't confuse that, so that you know that the meth, eth, prop, but, pent, hex, we use it for hydrocarbons, but for the last other 5 homologous series, we use the entire name of the alkane. We only remove the E at the end of the name. I hope you have understood that, which means if it's an aldehyde, it will be propanol. So you are able to see that now we are moving in that fashion. I hope that is able to help you. If it's a butane, it will be butan, for example, 2-one, if the double bond, because the double bond will be in carbon number 2, so it will be butan 2-one. So you can see that you write the entire name of an alkane, and then you only remove the E and replace it to get to the new homologous series. I hope that will be able to help you to say the prefix that we use for aldehyde, ketones, esters, alcohols, and carboxylic acid is methane, ethane, propanol, propan, butan, pentan, and hexane. So we're just removing the E at the end of the name. I have emphasized that enough to say for all these other homologous series is different when we are talking about alkanes, alkenes, and alkynes, the hydrocarbons, which we said is meth, eth, prop, but, pent, and hex. I hope that will help you when we do the naming of structure, because today we're going to focus mostly on naming of structures. Now, we said alkanes, their general formula is CnH2n plus 2, as you can see in our table there. Then the functional group of alkanes, how will you know them? You will know them because it will be a carbon-carbon single bond. You can see our single bond there, the 2 carbons in red and the bond in red as well, to indicate the functional group, the structure of the functional group of alkanes. Now, our description, we are simply saying it's a single bond between carbon and hydrogen and carbon and carbon. So you have to know that all the time. Our alkanes are like that. How will you know it's an alkene? You are saying the functional group, and then there you have a double bond there. The double bond there will show you that it's a carbon-carbon double bond. Then you know that this structure is an alkene. Alkynes is a carbon-carbon triple bonds. Haloalkanes, as I indicated, we are replacing one hydrogen with an X. X stands for, in our case, bromo or chloro. So we're going to replace the 1 hydrogen or 2 hydrogens with bromo or chloro. Then we know that now we are moving to haloalkanes. Now, alcohols, we are using OH. I will remind you, learners, about the definition of the functional group. Remember, we said a functional group is a bond, is an atom, like bromine, like bromo, like chloro. It's a group of atoms. So all these are functional groups. So you can see it's a bond, it's an atom, it's a group of atoms that determines the chemistry of an organic molecule. So I hope you know all these definitions. Remember, you have to get all the definitions, and we are saying for definition is 2 marks or nothing. So make sure that you understand all our definitions, and the only source that we are using for our definitions is our exam guideline. The exam guideline that we are using now is the 2021 one. So don't use the old exam guideline, use the 2021 one. You will be able to get all the definitions the way we'll be able to mark during the marking session. Now, if you see now, when you go to aldehydes, remember we're coming from CnH2n plus 2 for alkanes. So we'll be able to remove the 2 hydrogens, but the 2 hydrogens now we're replacing them with the oxygen. So it's a C double bond O. That's why we're removing 2, hence the bond there is double, because for each we'll be able to get the double bond from those removing of those 2 hydrogens. So you have to know that the general formula for aldehyde is CnH2nO. For ketones is CnH2nO. So you can see they have the same general formula. You will see when we do isomers, you will be able to understand why they become isomers, because they will usually have the same molecular formulas and different structures. You will see that when we deal with the isomers. Now, when you go to carboxylic acid and esters, you will see that is CnH2nO2. So it's the 2 oxygens that we are replacing with, unlike the aldehyde and the ketones, which were having only 1 oxygen. So you have to know that the one that is a C double bond O, only 1 C double bond O, that's one we are referring to it is for aldehydes and ketones. But for carboxylic acid, we have two oxygens. So we have two homologous series that we deal with that have two oxygens. It's our carboxylic acids and our esters. So you must be able to know all these functional group, and we are expecting you as well to know the name of the functional group. Remember, for aldehydes, we are saying the functional group is the formyl group or formyl group. So formyl group is for aldehydes. For ketones, the name of the functional group, it will be our carbonyl or carbonyl group. Our C double bond O there is our carbonyl group. So you know that is a carbonyl group. For carboxylic acid, the name of the functional group is the carboxyl group. So the carboxyl group, not carboxylic group, but carboxyl group. So you have to know that. And then we have the ester bond there for the esters that are formed. So these are all the functional groups that we're supposed to know. And for all these structures, we're saying know all their general formulas and know their structural formulas, know the name of the functional group. Functional group is very much important, more especially for question 2 when you are doing naming, because remember, you are having 9 different homologous series. So your duty is to know their functional group, because you only differentiate between different homologous series using their functional groups. So it's very much important that you know these functional groups so that you are able to differentiate the 9 homologous series, because the only way you will be able to know that this one is an alcohol is by knowing that OH or hydroxyl group is a functional group for alcohols. So it's very much important for you. We are saying you have 9 homologous series. For you to differentiate between them, you must know their functional group. So the question is, how will you know? Is by functional group. Functional group, very much important. I hope I've put more emphasis on that, and you will be able to write the homologous series. Now let's look at our alcohols. Alcohols, they can be classified. We have 3 types of alcohols. We have the primary, what we refer to as primary alcohol, secondary alcohols, and tertiary alcohols. We have given you definitions, straightforward definitions of primary alcohol is when the carbon that is bonded to the hydroxyl group. You see the carbon, this carbon, that is bonded to the hydroxyl group. You will forgive me. Remember I said for structural formula, show all the bonds. So you must be able to show the bond between oxygen and hydrogen. So all the time, show all the bonds. So we must write OH as O and a bond there, then hydrogen. Now, we are saying for you to define a primary alcohol, you will say is when the carbon that is bonded to the hydroxyl group is bonded to one other carbon. So you see this carbon is bonded to one other carbon, which is the carbon number 2. So you must be able to know primary means the carbon that is bonded to the hydroxyl group is bonded to one other carbon. However, when you move to secondary, like secondary, which means 2, so you can help you. Primary, you know, is the first school that you go to primary school when you start your school, but after that you go to secondary. So primary 1, the carbon bonded to the hydroxyl group is bonded to one other carbon. Secondary 2, so we're saying second means 2, which means the carbon that is bonded to the hydroxyl group is bonded to 2 other carbons. You will be able to define it like that. Tertiary alcohol, how will you know it's a tertiary alcohol? The carbon that is bonded to the hydroxyl group is bonded to 3 other carbons. So you define primary, secondary, and tertiary based on the number of carbon bonded to the hydroxyl group. The carbon bonded to the hydroxyl group, how many? The question you're asking yourself, how many other carbons is the carbon bonded to the hydroxyl group bonded to? If it's bonded to 1, you will refer to it as primary alcohol. If the carbon bonded to the hydroxyl group is bonded to 2, you will refer to it as a secondary alcohol. When the carbon that is bonded to the hydroxyl group is bonded to 3 other carbon, then that becomes the tertiary alcohol. Remember, we do primary, secondary, tertiary alcohols as well. We do primary, secondary, and tertiary haloalkanes. We can put a chloro there, then it will still be primary haloalkane, secondary haloalkane, and tertiary haloalkane. I hope you understand that. So we're saying no primary. Primary means the carbon that is bonded to the hydroxyl group is bonded to 1 other carbon. The carbon that is bonded to the hydroxyl group is bonded to 2 other carbons. We refer to it as secondary alcohol. The carbon that is bonded to the hydroxyl group is bonded to 3 other carbons. We refer to that as tertiary alcohol. Don't lose these free marks that you will get even in your exam. Now, when you are drawing your structural formula for organic compounds, what you have to know is that all bonds, you have seen I emphasized even the bond between oxygen and hydrogen there to say all bonds must be shown. So you show using either vertical lines, horizontal lines to show our bonds there, but all bonds must be shown. No part of the structure should be condensed. So when you say a condensed structure, is when you are writing CH3, or you can write CH2, CH3 like that. This is condensed. So we don't want, for structural formula, for technical science in grade 12, we are not dealing with condensed structures. We are dealing with structural formula, molecular formula, and general formula. As I indicated, I said we have 3 formulas that we are focusing on: general formula, molecular formula, and structural formula. So when the structure is written like that, for your information, you must know that that structure is what? Is condensed structure. Now, we are saying CH3 is condensed because the bonds between carbon and hydrogen are not shown. So immediately when you don't show all the bonds, the structure now becomes condensed. So you understand that. So we are saying even the bond between oxygen and hydrogen must preferably be shown as OH. So we are saying show this bond like this, don't show it as OH. So show it as O, show the bond between the oxygen and the hydrogen. So we are emphasizing that for structural formula, all the bonds must be shown. All hydrogen atoms must be shown around carbon atoms. Marks are deducted if only bonds are shown and not the hydrogen atoms. For example, if we say draw the structural formula of butane, what you just do like that. You see, it shows that you know that but is 4 carbons, but because it didn't show the hydrogens, that structure will be marked as wrong. So we are saying show all the number of hydrogens around all the carbons that we are having. I hope this is going to help you as you answer the questions, as we do the activities that we are going to do today, and as you prepare for your coming exams. We are saying writing of IUPAC names of organic compounds. These are the most important things that you must not forget when you are writing the names of organic compounds. We are saying hyphens are used between a word and a number. For example, we are having 2-methyl pentane. Methyl pentane, a word. 2 is a number, so there must be a hyphen between them. So don't forget that. Remember, we are saying if when you are writing exam, you don't write that hyphen, we are taking that 1 mark away. So just imagine losing a mark because you didn't write a hyphen. So I'm just pleading with you, write those. If there is a number and a word, ensure that there is a hyphen in between. Commas are used between numbers. So let's say you are having 2.3 dimethyl pentane, which means in carbon number 2 you have a methyl, in carbon number 3 you have a methyl. So di means there are 2. The other one is in carbon number 2, the other one is in carbon number 3. So what we are saying, between the numbers 2, 3, there must be a comma. So comma is between numbers, hyphen is between a number and a word. So I hope you got that, and you're going to ensure that you don't make those small mistakes that makes you lose marks. We must be able to obtain as many marks as we can when we write our paper 2 exams. So we're saying marks are deducted if hyphens and or commas are omitted. So we're going to take away marks. Imagine you got the structure of 2,3 dimethyl pentane correct. You wrote the correct name, but you didn't write the comma. You didn't write the hyphen. Imagine losing 2 marks for that. That will be not good at all. So we're saying ensure when you have 2 numbers, a comma. When you're having a number and a word, a dash or a hyphen. That's the right word that I'm using, a hyphen between a word and a number. So I'm hoping that we're still together when it comes to that. So we're saying all IUPAC names are written as 1 word. You see, this is 2,3 dimethyl pentane. I didn't say 2,3 dimethyl, then pentane there, somewhere there. Like it's a name in the surname. No, it's 1 name. It's 1 name. 2,3 dimethyl pentane, 1 name. So that's what we're saying. Except we have exceptions. Our exceptions is when we name esters and carboxylic acid. Only when we name those, we have 2 name weights in that name. So there will be 2 weights in a name only for esters and carboxylic acid. Remember, I said what is common between esters and carboxylic acid? I said all of them is CnH2nO2. CnH2nO2, all these. So they have the same general formula. So that will be giving you, when you do isomers, you will see why they are isomers then, because they have the same isomer, the same general formula. I showed you the general formulas for aldehydes and ketones as well as CnH2nO. I said they are the same. So it must tell you that there must be a relationship between them. So you will see when we do isomers, you will be able to identify them, that they will give us isomers. So we're saying esters and carboxylic acid, they have the same general formula. And when you write their name, you write 2 ways, not 1 weight, 2 ways. For example, you will say propanoic acid is not 1 weight. You can't write it as propanoic acid as 1 weight. There'll be a space between propanoic and acid. So it only applies for carboxylic acid and it applies for esters. For example, when you're writing an ester called ethyl propanoate, so it will be 2 ways there. So let's ensure that we do that. Then we are able to do that, as compared to methyl propane. Methyl propane, you can see, is 1 weight. Chloromethane is 1 weight. But for esters and carboxylic acid, we have 2 weights. I hope I was able to summarize nicely how do you go about doing IUPAC naming, which is the focus of today, because today we want to focus mostly on doing activities. So we are here to be dealing with more of activities. So when you are naming your alkanes, what you do, ensure. Remember what we said. We said alkanes, they can be branched, they can be straight chain, and then, for example, you are having here the structure with 1, 2, 3, 4 carbons. You will remember what we said. We said 4 carbons is in this case, is the longest carbon chain. So the first thing, you will identify the longest carbon chain. You identify the longest carbon chain. That is the first thing you will do. You identify the longest carbon chain to say, okay, let me start on the right. Why am I starting on the right? Because when you are numbering, you must always number closest to the substituent, closest to the branch, closest to the side chain. Remember the names that we used for this branch. We said this is our branch, is our side chain. So when you number, you must number closest to it. But when you have a functional group, you number closest to the functional group. You will see when we do other names. So in this case, this will be carbon number 1, carbon number 2, carbon number 3, carbon number 4. Why not 1, 2, 3? If you number from here, you say 1, 2, 3. It's not the longest carbon chain. So make sure that you look for the possible longest carbon chain. Don't just number the longest chain as you see it. No, go through it and say 1, 2. If you go to the branch there, you'll say 1, 2, 3. But you see that this is not the longest, because we're having 3 carbons in that chain. But if you go straight, you'll have 1, 2, 3, 4. Then you know that the 4 carbon one is the longest carbon chain. Remember what we said for alkanes, alkenes, and alkynes. When we name, we'll say meth, eth, prop, but, pent, and hex. So because it's 4 carbons, you know it's a but. It's a but, which means 4 carbon, and it's saturated. When it's 4 carbons, it's saturated, and it's a hydrocarbon, you know it's an alkane, so it's a butane. But you must be able to tell us that in carbon number 2, we are having a methyl. Remember, we said CH4. CH4 is a methane. We said CH4 is a methane. But immediately, when you remove one hydrogen from methane, it now becomes methyl as a branch, as a side chain. It's now methyl. So it's no longer a methane, because for it to qualify to be methane, it must be 4 hydrogens around it. But we are having CH3 here with 3 hydrogens. So it can't be methane, 2-methane, butane. It's not methane, it's methyl, because it becomes an alkyl, because we have removed 1 hydrogen so that we can substitute nicely in carbon number 2. I hope you have understood that. Then our name will be 2-methyl butane. Remember, we're having a number and a weight. So there must be a hyphen. I hope that was helpful to yourself. So that's how you go about numbering your structure. And I wanted to show you as well here to say you can start numbering from here, because most of the time, our learners think that the longest chain must be the one that is straight. It can just start from here. Is 1, 2, 3, 4. This is still correct. It's still a longest chain. Then this will become still 2-methyl, because in carbon number 2 we have a methyl group there. So it's 2-methyl butane. So in your numbering, look for all the possible numberings that you can have, so that you are sure of the name that you are giving to the structure. So this is our structure. We are referring to it as 2-methyl butane. Hoping that you are enjoying the lesson. Now, I summarized here for you. When we are giving you this summary, learners, we are simply saying this IUPAC stands for International Union for Pure and Applied Chemistry. So that is to say, this naming is used international, not only in our country. It's international, where how do we name? Hence, we say IUPAC naming. So you can't name outside of this if you are naming organic molecules, because internationally, even in other countries, they must be able to name the same name, the same way that you are naming in our country. So it's very much important that you understand that. So we're saying we have the prefix. Now, the prefix is what the name will start with. The name will start with a substituent. Remember, if we have a substituent, remember I said our substituent can be methyl or ethyl. Those are the substituents for text science grade 12. And then our other substituent can be bromo or chloro. So those are our substituents. So all our names, if you have a substituent, our name would always start with those prefix. Now, how many carbons? The longest carbon chain, it becomes the base, the parent chain. We're looking at how many carbons. Then you're going to look at the number of carbons. Then you go back to the meth, eth, prop, but, pent, and hex, as we discussed. Now, to get the suffix or the ending of the name, for you to get the ending of the name, you will be able, for example, in the question that we were doing in the previous question, we had a 2-methyl butane. The butane was, the methyl was in carbon number 2. So the same here, if it's a methyl, then if this substituent, you must tell us in which carbon do we find the substituent. So it's important that this substituent is given a number to say in which carbon. In which carbon, unless if we are having only one, for example, if you are having bromomethane, for example, it will always be in carbon number 1. So you don't necessarily have to, say one bromomethane, because the bromo would always be in carbon number 1, because there is no any other carbon. The other one will always be bromoethane, for example. Bromoethane is one bromoethane. It will always be one bromoethane. So it's not necessarily important for you to indicate where the substituent is. So it's very much important. But immediately when we move to 3 carbons, for example, when you have 3 carbons and a bromo there, you are able to say, okay, now when you look at this structure, we can be able to say, let me draw the structure for you so that we can name it nicely. So remember, we said the name must start with the prefix. What is our prefix? It's a bromo. Now, I said we have only those 4 substituents that we talk about. So bromo is in which carbon? It's in carbon number 2. So that's why it's important that you first number the longest carbon chain, which will be 1, 2, 3. So that when you write bromo, you say 2 bromo. Because it's 3 carbon, you know is propane. Don't forget, we said only esters and carboxylic acid have 2 ways. The rest is 1 way. So this will be 2 bromo propane. So you're able to get that structure, and you got everything. You have adhered to the rules for IUPAC naming. So it's very much important. We don't name our way. We have rules for naming. Which I'm saying the first important rule, which is the most important one, is that you identify the longest carbon chain. You number the longest carbon chain. Then from there, it will be able to give you our base to say how many carbons do we have in that chain. Then you look for the homologous series. How do you know the homologous series? It is the functional group. So the functional group will tell you whether it's alkanes, alkenes, alkynes, haloalkanes, and all that. So you look for the functional group. It will be able to help you to identify the homologous series. When you know the homologous series, you will know the suffix of the name. Remember, the suffix comes from the homologous series. I hope this slide will definitely help you, and you are writing your questions. Remember, we said our number is still 060-667-5044. So if you have any question pertaining to our topic of today, this is question 2 in your exam. So it's very much important that you do well here in this question. Now, as I indicated, that we're going to do isomers, structural isomers. So our structural isomers, the first one, we call it chain isomers. So the first one is what we refer to as chain isomers. Chain isomers. Remember, when I started, I said we have branch and unbranched chains. So immediately when we have branches, we are starting to have chain isomers. So that's what is happening. In this, I use the example of butane, for example, which is 4 carbon. Butane is 4 carbons. So I'll just quickly write the structure of butane. You have it there so that you can be able to understand what do we mean chain isomers. If now you can look on the example there that I gave of 2-methyl propane. So if now we take in carbon number 2, we have a methyl. If we have a methyl now in carbon number 2, as I do this quickly for you so that you are able to follow, where are we coming from? So when you define with understanding, because the first question will say define chain isomers. Define chain isomers. So you must be able to say, remember, these are organic molecules. So you will always start by saying organic molecules with the same general, same molecular formula. So you will say same molecular formula. So for all isomers, the molecular formula must remain the same. So we're saying for chain isomers, you will say organic molecules with the same molecular formula. For positional isomers, you will say same organic molecules with the same molecular formula. For functional isomers, you'll say organic molecules with the same molecular formula. So that one is given, that the molecular formula must be the same. So how do we get molecular formula? We count the number of carbons and number of hydrogens. All the atoms that are involved, you must be able to know their number. Let's start with carbon, for example. We have 1, 2, 3, 4 carbons. So you will say C4. If I can write it here, C4. Now we count the number of hydrogens. Which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10 is a molecular formula. Ne? This is the molecular formula for butane. Now, if you look at 2-methyl propane, as well, you must count the number of carbons. Is 1, 2, 3, 4. So it's still C4. The number of hydrogen is 3, 6, 7, 8, 9, 10. So it's still C4H10. So you can see that the chain isomers, they have the same molecular formula. So that's what we're talking about. So all the time, you must know how many atoms that we are having. So around the carbons, how many carbons we have, how many other atoms we are having around the carbons, so that you can be able to get the molecular formula. If they have the same molecular formula, then you look at what is different. What is different is chains. I said we have 2 types of chains, branch or straight. So you can tell here that, chain isomers, they have the same molecular formula, but different types of chains. The other one is branched, the other one is unbranched, but the molecular formula remains the same. Remember, you have to always know that we have chain isomers, positional isomers. Now, when it comes to positional isomers, we can use, for example, your haloalkanes. For example, if we take the structure, for interest sake, if we take the structure so that let me erase so that we have the space there so that I can be able to show you. If we take the structure of chloropropane, 1 chloropropane, as we are having there, 1 chloropropane. Let me show all the bonds and the hydrogens so that you know that it's important. Remember what we said, each carbon must always be surrounded by 4 bonds around it all the time. Ensure 4 bonds around the carbon, because when we're marking, we're always looking for that. If we find that there are more than 4 bonds around each carbon, we are going to lose marks. So this is the structure of 1 chloro, because when you number, I said start from there where the functional group or where the substituent is. So our substituent is chlorine there. It's in carbon number 1. So this becomes carbon number 1, number 2, number 3. You know 3 is for prop. It's saturated. There is no double bond. So this is propane. So in carbon number 1, we have a chloro. So the structure will be 1 chloropropane. Remember, I said 1 name. The name must be the same. So that will be 1-chloropropane. So we got the structure of 1-chloropropane. But we can take this chlorine and put in carbon number 2. So the structure now will change because we'll be having chlorine in carbon number 2. Then that the name now will be 2-chloro because the chloro is in carbon number 2. The name will be 2-chloropropane. So you see now, these are referred to as positioner because what differs is the position of the chlorine, which is our substituent there. So you can see the substituent is in carbon number 1, the substituent in carbon number 2. So you know, okay, this one's what is changing is the position. So what are positional isomers? We're saying organic molecules with the same molecular formula, always same molecular formula, but different position. Position of what? Of the chain, of the side chain, of the substituent, and of the functional group. So I usually will say SSF so that you don't forget. So we're saying same molecular formula, but different positions of the side chain. So it can be side chain, it can be substituent, which is our remember we said our side chains can be our ethyl and methyl. Our substituent we refer to our bromo and our chloro, and then our functional group as well. Now I've shown you with the substituent to say with the substituent you have seen our substituent there. Our substituent there is in carbon number 1, is in carbon number 2. So that is, those are positional isomers because we have different position of the substituent. The substituent is in different position. Remember, we said chlorine is a substituent because it's substituting one hydrogen. Where there was a hydrogen, we've put a chlorine there. So we're referring to it as a substituent. I hope that clarifies. So we're saying the positional one, we're changing the position of the substituent or the position of the functional group. So for the functional group, I'll use example of butane, for example, butene. When we have a double bond, we can have a double bond in carbon number 2, carbon number 1, which is but1-ene. Remember, when we're drawing these structures, we're saying ensure each carbon must have 4 bonds. So always count the number of bonds around the carbon because you want to ensure that it's carbon is tetravalent. It can only form 4 bonds around it. So now, when you're having that structure of but1-ene, why do we call it but1-ene? Because the double bond is in carbon number 1. So when you number, always start where there is a functional group. So this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. So 4 is a but. Where do we find a double bond? In carbon number 1. So we say but1-ene. In, we took it now because these are alkenes. So if we move the double bond to carbon number 2, it becomes but2-ene. So you see now, when we draw the structure, it will now be having double bond in the middle there. Then you must be able to know that, oh, now we are talking about but2-ene. But2-ene and but1-ene, they are isomers. What type of isomers? Positional. Because what is different? What is the same all the time? We're saying the molecular formula. But for positional, what is different? We're saying what is different is the position of the functional group in this case. In this case, what is different was the position of the substituent. Hence, we're saying in our definition is the same organic molecules with the same molecular formula, but different position of the side chain, of the substituent, of the functional group. I hope you will be able to remember that as you do these isomers. So know all these isomers. Then the last part of our isomers that we talked to was the isomers that we have referred to as functional isomers. You will remember I referred to aldehydes and ketones. I said they have the same general formula, which we said the general formula is the general formula for aldehyde, we said is CnH2nO, and the general formula for the aldehyde and ketones, they have the same general formula, which is CnH2nO. So you will know by having the same general formula, then they will be able to have the same molecular formula. So when they have the same molecular formula, but different, let's look at it now. Let's draw the structure, for example, like that, where we're having the C double bond O between the 2 carbons, which is the structure of propanone. We have the structure there. Remember what we said? Each carbon, 4 bonds maximum. So always check that. So we're saying, okay, this is 1, 2, 3. So we have 3 carbons there. Then our structure will be able to be propan. Remember I said you write the whole name now, because it's only for haloalkanes where you write prop. But for this one, you say propan. You are only removing the E. Now, where there was an E, we're going to use the homologous series so that we're able to get the structure. Because this one is a ketone, so it will be propanone. Propanone. But if I am to draw another structure, for you here with a C double bond O with a formal group, you will see now we're having that structure there. Yes. Hydrogen, it look nice. Now you must be able to see now that we are having if you check molecular formula, let's check how many carbons do we have. 1, 2, 3. So it's a C3. How many hydrogens? 1, 2, 3, 4, 5, 6. H6. How many oxygen do we have? And O. Let's go to the structure. Let's check the molecular formula of, remember, molecular formula is simply counting how many carbons, how many hydrogens, how many oxygens, all the atoms. So here we have 3 carbons as well. We have 6, 3, 3. We have 6 hydrogens and an oxygen. So you can see these propanone and propanal, they are functional isomers. Why? Because they have the same molecular formula. So we're saying all of them, when you define isomers, you'll always say same molecular formula. So they have the same molecular formula, but what differs between them is their functional group, because propanal is for aldehyde, which we said is a formyl group. Remember we said it's a formyl group. And then propanone is a ketone, which is said they have carbonyl group. So you know that the functional groups are different. So you always look for what is different. What is the same is always the molecular formula. So for us to have isomers, we are saying they must always have the same molecular formula. And then depending on the name, you look at what is different. We say when the difference is the different types of chains, branch and straight chain, you will know that different type of chains, then that will be chain isomers. If it's different position of the substituent, of the side chain, or of the functional group, you will refer to that as positional isomers, because it's a different position. When it's different functional groups, so it's a functional isomers. So we're saying functional isomers, you are having aldehyde and ketones. If you can look for functional isomers, that's when we are having different functional groups. But all other isomers, you will see that they will all be belonging to the same homologous series. But only functional isomers, they belong to different homologous series. So all the time you know that if it's two different, if the homologous series is the same, you will know that these can either be chain or positional isomers. But if the homologous series is different, it can only be functional isomers. I hope you will be able to remember these isomers when we do the questions, because they will be part of the questions. Activities, as I indicated, our lesson is going to be mostly about activities, mostly about you practicing how to answer questions. Now, let's look at the multiple choice questions. Remember what we were saying? We're saying you are given 4 options for multiple choice. Of the 4 options that you are given, we are saying there are 2 that are just there to disrupt yourself. We refer to them as disruptors. So we have 2 disruptors. So you have to remember, one, if you have 1 out of 4 chances, that is 25% chances. So your chances are very slim to get the correct answer if you are choosing out of 4. But if you can eliminate 2 disruptors, you will remain with 2 options. So it becomes easier for you to be able to get the answer. So what we are saying, what you must do is that remove the disruptors first. Don't be in a hurry. Remember, you have 2 marks for each multiple choice questions. So the 2 marks, you have about 2 minutes, 2.4 minutes. So you have a lot of time to answer this question. 2 minutes to answer the question. So ensure that you remove the disruptors and you are able to choose the correct answer. Let's look at this first question, which says, to which homologous series does the molecule C8H14 belong? You see, you are given molecular formula. So this is very much important. You are given molecular formula. And then the only way that you can be able to get this is when you know the general formula, because if you know the general formulas, they will tell you what happens. Remember, general formula for alkanes, we said is CN H2N plus 2. So if this C8H14 is an alkane, it means it must be C. We said the N is the number of carbons. So number of carbons is 8. So you will say C8 H 2 times 8 is 16 plus 2 C8H18. The alkane with 8 hydrogens, the alkane with 8 carbons must have 18 hydrogens. So this is not an alkane. Now you move further. Obviously, you know that from alkanes to alkenes, you remove 2 hydrogens. So you are able now to say, okay, let's remove the 2 hydrogens, C8H16. That will be an alkene. For alkyne, you remove further from alkene, you remove further 2 hydrogens. So that will be C8H14. Look at that. Look at the beauty of that. Then you're able to say, oh, this one must be an alkyne. But when it comes to removing disruptors, definitely you will know that alcohol is a disruptor. Why is alcohol a disruptor? Because alcohol must have an OH. We don't have an OH there. So you must remove. You know that alcohol will never be your answer. And the other thing, you will know that if it's 8 times 2, obviously it must be 16 or more for the number of hydrogens. When they are less than 16, you will know that no, this must not be an alkane. So this was not going to be an alkane, but the 2 possible answers for you would have been an alkene and an alkyne, of which in this case we got the answer is C8H14 is an alkyne, because we have removed 2 to get C8H16. We remove another 2 to get C8H14. I hope that helped you. So you are able to choose C as your answer. Then you are able to be rewarded your beautiful 2 marks. So you are moving now. Remember, in the exam, multiple choice, these marks, let's ensure that we collect them. Now, the question now is, what is the general formula of the haloalkane? You know haloalkane. We said halo, which is bromo or chloro, is a substituent. It's going to substitute 1 hydrogen. So obviously, you can see here we have removed 2. So this one is just disrupting us. This one as well, we have removed further 2. So this must be an alkyne because of the number of hydrogens removed. So you are left with those 2 options, of which you will know that for us to get a halo, we must be able to remove substituent. Halo is a substituent, so we have removed 1 hydrogen. We put the X there, so you know that the answer for this one is number D. Then well done, you get your beautiful 2 marks. You get your beautiful 2 marks. So I hope you are able now to understand as we move forward. You are able to understand so that we don't have problems. You are able to move with us. So I hope you are able to do those 2 multiple choice questions, and you understand how they must be done. Now, as we move forward, we are going to look at other questions, and I hope you are understanding this and you are looking at this, and then you will be able to see this question. Now, with no any wasting of time, we'll be moving to the next slide as I navigate for you. So I hope you have seen that with multiple choice, that's what you will be able to do. So I will be able to say when I come back, we'll be able to continue with the multiple choice questions. So you will see that this is how we do multiple choice. When we finish the multiple choice, we go to structured questions because we want you to get all these marks. So I would like to say thank you very much for just taking you a short break. Then immediately we're coming back to continue with our lesson. Thank you very much.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing because this can be done and you can be great.
Welcome back. I hope you were able to drink water and then we can move on with our lesson. Now let's look at question 1.3. Still multiple choice. It's saying which one of the following compounds is an example of saturated. Remember what we said. We said saturated. Look at the S there. It stands for single covalent bond between carbon atoms. Don't forget, unsaturated, it means now we no longer have single, we have double or triple bond between carbon atoms. So you are able to understand that. So we're saying saturated, there must be single covalent bond between carbon atoms. So you know that, okay, we're looking for single. Now, obviously, ethene is not single bond, it's not saturated, it's unsaturated because it's an alkene. Butane, yes, it can be the answer. Bromoethane, yes, can be. Methanoic acid, it's not a hydrocarbon, this one. This one is a haloalkane. You can see as I answer multiple choice question, I go through all the given options. So you don't have to be excited and choose the answer so quickly. No, look at all the given options so that you are able to get the right answer. So we're going to choose butane because it's saturated and it's a hydrocarbon. I hope you understand that. Then you will get your 2 marks there. Now we move to 1.4. It says which one of the following is the functional group of the alkenes? Alkenes, you will know that OH is an alcohol, COH is a carboxylic acid. So you know number C and D are disruptors. So always look for those disruptors and remove them immediately. Then you're saying, my options is either A or B, but it's alkene. You know alkene is double C, carbon-carbon double bond. So you're able to choose A as your answer. You get your 2 marks. I'm hoping you are doing the same as you look at the question. Look at that one. The structural formula of an organic compound is given below. So look at that structure. You can even try to answer the question. I'll just give you a minute to look at that question to say which one of the following is the correct IUPAC name of the organic compound above. So look at the structure. Remember the rules. You must follow the what? You must follow the rules. Now you look at that. Having looked at the structure, you will say, okay, which one is the correct one? Let's look at option number A, for example. It says propanone. You know, propanone, we must have a 6 double bond O surrounded by 2 other carbons. So that cannot be because this is a ketone. A ketone, you know its functional group. It must be a carbon C double bond O surrounded by 2 other carbons. So that cannot be an options. Propanoic acid. At least with propanoic acid, you know the general formula is CN for carboxylic acid is CnH2nO2. For option C and D as example as well, they have CnH2nO2. Remember we said the esters and carboxylic acid, they have the same general formula. So these ones, at least they are related because they have the same general formula. So you can now go and say, okay, the right one for this one would be, you look at the functional group. How will you know? I wanted to tell you this one to say all the time, for you to identify the homologous series, look for the functional group. The functional group will tell you which homologous series is this one. So if we can look, our functional group is a C double bond O and another oxygen there. So you see that this must be an ester. This must remember there are only 2 homologous series that have 2 oxygens within the structure. We said it's CnH2nO2 for carboxylic acid and for esters. So it's either an ester or a carboxylic acid because we have the 2 oxygens there, CnH2nO2. Now, what we have to look at the structure, you can see that this will have been this will have been our alcohol. This will have been an alcohol, which was methanol. Remember, to form an ester, we're saying you are having an alcohol, in this case, methanol, plus a carboxylic acid, in this case, which is 2 carbons, which is now ethanoic acid. So you are having ethanoic acid and methanol. The alcohol becomes the alkyl group. So this was an alcohol. So this will be methyl. So you look, when you are naming an ester, you look for an alkyl group first to say, where do we find the alkyl group? So you can see that, okay, this one that goes C double bond O is part of the chain, but the alkyl group is methyl. So you are having methyl ethanoate. So you will be able to look at that methyl ethanoate. Remember, the OH one is the one that has a C double bond and the oxygen. So you have to be careful of that. So the structure that is going with this will be our ethanoate, which is 2 carbons. But our alkyl group now becomes methyl ethanoate. Then you are able to say, oh, I'm taking option D. You can see that in all multiple choice questions that we are answering, we first work them out. You can look at the structure and be able to come with the correct answer. Work it out, enjoy it, do it, and be sure of it, so that even when you reach home, you tell people that you have passed technical science, you will have passed indeed the subject. Now let's look at question 1.6, which says, which one of the following statements regarding alkanes is correct? So now, in bold letters, the word that the one that is given in capital letters or bolded, you must know that that is the keyword that you are looking for. And the other keyword there is the word correct, because we are looking for the correct statement about alkanes. So we are saying alkanes are unsaturated. You know, alkanes, they are not unsaturated. So this becomes wrong. Alkanes, look at number C. Alkanes contain at least one double bond between carbon atoms. You see now, you can see at least one double bond. Double bond. Alkanes, no. Alkanes contain at least one triple bond. Triple bond, no. So you know that your answer for this option is B, because you know that alkanes are saturated. So you are able to get your 2 marks. So work as many multiple choice. Remember, we're having all these question papers from 2018 to 2021. You will be getting another question paper now when they write the exams now, the junior exams. There'll be another extra question paper. Use all these question papers for revision and do all the multiple choice questions, because most of the time we lose these marks because you take multiple choice for granted. But I know with you, you will ensure that you do as many multiple choice questions as we have done in this session. Which one of the following homologous series contains a carbonyl group? You will remember a carbonyl, we said, oh, a carbonyl is a C double bond O. C double bond O. So you will say, oh, okay, alkynes is a C, is a triple bond, is a carbon-carbon double bond, alcohols, the OH. So the only option that we have is that one of the formal group, because in the formal group, we still have the C double bond O. So you are able to know that the option there is D. You get your 2 marks. I hope we have done as many multiple choice questions as possible. I think this will be our last multiple choice question. Sorry, to say, consider the organic compound represented below. So you look at the structure. Remember what I said. You identify the longest carbon chain, which should say, okay, the longest carbon chain, you saw it is 1, 2, 3. 1, 2. Why this carbon is number 1? Because you always start numbering where there is a double bond or where there is a functional group. So because in carbon number 1, we have the functional group. This is carbon number 1. This is carbon number 2. Remember what I said. It doesn't matter whether you go straight or you go there. This can still be carbon number 3. So it's still fine. You can say 1, 2, 3 or 1, 2, 3. Doesn't matter. They are all fine. So you can see that the number of carbons is 3. 3 carbons is prop. Remember, we said for hydrocarbons, we're using that meth, eth, prop, but, pent, and hex for the number of carbons. So when there are 3, it's prop. But in carbon number 1, always don't forget between a word and a number, there must be a hyphen. So it's prop 1 because the double bond is in carbon number 2 because its double bond is in. So the parent chain is prop 1 in. Now you have the side chain in carbon number 2 because it's a methane, but with running short of 1 hydrogen, we said it's 2-methyl. So you remember that is 2-methyl. 2-methyl prop 1 in. Remember one name. We said one name except for carboxylic acid and esters. The rest, the name must be only one. So we're saying 2-methyl prop 1 in is the name of the structure. So the question was not saying it was saying consider the organic compound represented below. So I took advantage of the question so that you know how to name these structures. But the question was saying the above compound is saturated and branched. Let's look at that. Is the above compound saturated? No. Is the above structure branched? Yes. So it fails because only one part is correct. The above structure is number C, saturated and straight chain. It's not saturated, it's unsaturated. It's not a straight chain, so it's wrong. The above structure is unsaturated. Yes, it's unsaturated because it has a double bond. And straight chain, no, it's not straight, it has a branch. Hence, our answer will be number B. Then you will be able to get the 2 marks. So those were multiple choice questions, and I hope you have understood and you will do for each question that you are doing. Now, let's look at these questions. They are all taken from previous question papers. Now, when you receive a question paper, question 2, you can be given a statement and then the table like this one. Sometimes it will only be statement and then question. It doesn't matter. But if you find a question in this format, so what you have to do, they are saying the first thing which is very much important, you see it says question 2, start on a new page. It's a simple instruction, just start on a new page. And it's saying A to F in the table below represent 6 organic molecules. So you know all of them are organic molecules from different functional groups. So they are telling you that they have different functional groups. Now, remember, I want to give you this strategy to say, when you get a table like this, use this FH-GMS to answer this question. It will help you this strategy that I'm giving you, because most of the time our learners are in a hurry to go and answer the questions without even understanding what is given on the table. Remember, all the questions that you are going to be asked are based on this table. So it's important that you understand the table before you answer the questions, because if you go straight to the questions without understanding the table, you are going to have a problem. So it's very much important that you first understand the table. So this FH-GMS is going to help you. So the F, the first thing which is very much important is the functional group. That F stands for the functional group. So first, look for the functional group to say what is the functional group. For all of them, know their functional groups to say what is the functional group here is C5H12. You can see already 5 times 2 plus 2 is 12. So you can see that that will be alkanes. This will be an alkane, this one, an alkane. Now, first, the functional group, it tells you the homologous series. So because of CN, H2N plus 2, which is C5. 5 times 2 is 10 plus 2 is 12. So you know that this is an alkane. So the first thing, you looked at the functional group, then you saw that because of the general formula gave you that, then you are able to get the alkane. Now, the homologous series is the alkane. Let's look at the second structure, which is B. You are having carbon-carbon triple bonds. So what is this functional group? It's a functional group for alkynes, which is the homologous series. So you know that this is a homologous series here is alkynes. So because of the functional group, which is the F, you are able to get the what? The homologous series. Now from there, the G there stands for the general formula. You know, for alkynes, the general formula is CnH2n plus 2. From there is the issue of the molecular formula. Then you have to know the molecular formula. This is the structural formula that you are given. So the I there for the isomers and the N for the name of that structure. So this is going to work wonders on number C. Look at number C. I'm saying when you get a question, you will say, what is the functional group here in number C? You look, oh, the functional group, you said is an atom. It's a group of atoms that determines the chemistry of an organic molecule. So what differentiates this from all the others is the bromine there. So that is our functional group, which is our substituent, our bromine there. So you know this now, because of the bromo, you know that, okay, we have identified our functional group. What is the homologous series? Is haloalkane. So you are able to say, okay, haloalkane is the homologous series. Then what is the general formula? Remember the issue of general formula? I said, yeah, general formula for haloalkanes is CnH2n plus 1x, because we are simply replacing or substituting one hydrogen with a bromine there. So you know that the general formula will be that one, which is the Ge there. Now, what is the molecular formula? Molecular formula, we said you check how many carbons, how many hydrogens. So you are able to say C4, there are 4 hydrogens. You number from closest to the functional group or the substituent, which is bromo in this case. So this will be C4 because we have 4 carbons. So it's a C4. How many hydrogens? You will be able to say 3, 4, 5, 6, 7, 8, 9. C4H9Br. So that is your molecular formula. So your molecular formula, because when you ask questions, we'll ask you what is the functional group, what is the homologous series, what is the general formula. The next question, what is the molecular formula? So you count, you say, the molecular formula, I got it. What is the structural formula? It was given in this case. So that is the structural formula. So you are now able to check, do all of that. Does this structure have isomers? Remember isomers? Isomers, we said, okay, the bromine can be in carbon number 1. So that will be a positional. So you know that because it is bromine, it can have a positional isomer. Can have a positional isomer where the bromine can be taken to another carbon. So you know that you are expecting, if there is any question about isomers for this structure, it will be positional isomer. Now you check what is the name. The N there is for the name. So the name of the structure, in carbon number 2, we have a bromo. So you'll say it's a 2-bromo, 4 carbons. You said it's boot. Saturated, there are no double bonds, so it's an ane. So this is 2-bromo butane. Look at that. So you were able to answer any question. There is no any other question. We will be asking you these questions around this. So it's important that when you look at that FH-GMS, you know that I've done justice in terms of this structure. You will see when you go to the question, this will have answered almost all the questions that we are going to ask you. So if you go to number D as well, you will do the same to say what is the functional group? It's this carbon-carbon double bond there. So this must be alkene. The homologous series must be alkene. How do you know it's an alkene? Because of its functional group. So you always start with the functional group, then it will tell you which homologous series it belongs to. So you know that this is an alkene. Then we say, what is the general formula for alkenes? Is CnH2n. CnH2n. Remember, for alkenes, we said for us to get a double bond, we remove 2 hydrogens. So you are able to get CnH2n. Then what is the molecular formula? You see now, we are moving. What is the molecular formula? You're saying, okay, it's we're having, how many carbons do we have? 3. So it's C3. How many hydrogens? 1, 2, 3, 4, 5, 6. C3H6. So that becomes your molecular formula. Now the next question will be, what is the structural formula? Is what is given there. We're given structural formula. What are the isomers? Does it have isomers? You will be able to look at the structure and say, okay, are there any possible isomers that we can get if we play around the structure? Because if you take this CH3 to this carbon, it will remain that. If you take the double bond to this carbon, it will remain that. So you see that it's going to be very difficult for you to get isomers of that structure. So you won't be talking to isomers. Then you say, what is the name of this structure? The name of the structure will be, we always identify the longest carbon chain, which is 1, 2, 3. So that is your longest carbon chain. And then you say 3, For hydrocarbons is prop. 3 is prop. And in carbon number 1, you have a double bond. So it's prop 1 in. But now, because the double bond for propene is always in this carbon, because if you bring the double bond here, it will still be prop 1 in. So we will just refer to the structure as propene. However, when you move to butene and all the other alkenes, you will indicate the position of the double bond. But in this case, we are saying the double bond is in carbon number 1 at all times. So there's no need for you to be saying prop 1 in is propene. Will accept the name. So I hope that helps you. We go to the fourth structure that we are having there, which in this case we said, okay, remember our FH-GMS. What is the functional group? You know, it's a C double bond. This is what differentiates this from other structures. It's a C double bond O and a hydrogen. You know, this is a 4-mile group. It's a 4-mile group or 4-mil group. And then this is for aldehydes. So you know, it's an aldehyde, this one, C double bond O, and in H is an aldehyde. Then you know that it's an aldehyde. So you see, the functional group tells you the homologous series. Then you say, what is the general formula for aldehydes? Oh, general formula is CnH2nO. We said there is only one oxygen because it's a C double bond O. So that is the general formula. And then we say, what is the molecular formula? Molecular formula, you count the number of atoms. How many carbons do we have? 1. Remember, you always number from the functional group. So it's 1, 2, 3, 4. So you know that is 4. Remember, we said it's only for hydrocarbons where we use the meth eth. Here we say, because it's 4 carbons, we say butane. You write the whole name without E. The only thing you remove is the E from all the other 5. It's only when we're dealing with the first 3 that we said that you will say meth, eth, prop, but, pent, and hex. But in this case, you will say, no, this one, because it's the aldehyde, so you just say butane, you write the whole name, you remove E, then you take the Al there from aldehyde, you refer to this as butanol, which is the name of the structure. So now the other question that you are going to ask yourself, you will say, does it have any isomers? Yes. Remember what we said? Aldehydes, they go with ketones. Ketones, they have the same general formula, so they must be relatives. So it means now, if we have a ketone, because we can ask you to write down the structural formula of the isomer of F. We can ask you to write the structural formula of the isomer of F. So what you have to do is just to move the C double bond O to carbon number 2, for example. Then you have your structure like that. Hoping you are able to see the structure. Then you have your structure like that with your hydrogens. Now you can see the 2. If you look at the molecular formula for this one, is a C4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. H8O. C4H8O. Now when it goes now to the ketone that is the isomer there, you can count as well to say it's 1, 2, 3, 4. So it's a C4. H is 3, 6, 8. So it's still C4H8O. So you're able to say, oh, they have the same general formula but different functional group, because this functional group we said is the 4-mile group. This one we said is the carbonyl group. They just have the carbonyl group, but this one is the 4-mile group. So you know that these are aldehydes, these are ketones. So they have the same general formula but different functional groups. So we refer to this as functional isomers. Look at the beauty of that. So if you are going to apply this strategy in all the questions that you will get, to say I will always seek to find the functional group, which will tell me which homologous series does it belong to. When I know the homologous series, I will know the general, I will go to the general formula, I will go to the molecular formula, I will go to the structural formula, isomers, and naming of the structure. So if you do this for all the structure you come across, you just say FH-GMS, you are able to do very well here. I'm hoping this is helping you and you will enjoy this section, and you are looking for totals as you get this in the exam. As I indicated, that not all the time you will get a table, the question in a table form. Look at this question. It's not in a table form. It's saying question 2, start on a new page. Organic molecules are used in a variety of industries, including food, pharmaceuticals, fuels, and construction. They include homologous series such as alkanes, alkenes, alkynes, haloalkanes, alcohol, carboxylic acid, ketones, aldehyde, and esters. So you're given our homologous series there. They were named there for you. Now, the first question was define the term homologous series. Remember, we said for you to define the term homologous series, you must know that they are described. This is a series of organic molecules. So you will always say this is a series of organic molecules. Always organic molecules, because we are talking about organic molecules. These organic molecules, they are described by the same general formula. So they are described by the same general formula. They are described by the same general formula. Remember, we said each member differs from the next. Each member differs from the next. By CH2 group. So that's what you said. Two things. You are saying they are described by the same general formula, and each member differs from the next by CH2. I think a simple example would be CH4, CH3, 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 CH2, CH2, CH3. If we look at these structures which are condensed, I indicated that we don't do condensed, we do structural formula. So you must draw and show the bonds. I just want to show you that here, the difference between this structure and this structure is a CH2. So hence we refer to it as a homologous series. They are in the same homologous series. Why? Because each member, this member, differs from this member by I should have done 3 carbons there. So this member differs from this member by a CH2. And even you can check the difference between CH4 and the CH3, the difference is still CH2. So hence we call them homologous series. So we're saying they are homologous series because each member differs from the next by CH2. We are saying they are called homologous series because they are described by the same general formula. So you have to know that definition of what is homologous series. You'll be able to get your 2 marks. So our keyword we are looking for, described by the same general formula, and each member differs from the next by CH2 group. I hope you have understood that. Now we have question 2.2 that says identify any one homologous series that is a hydrocarbon. You will know. We said we have 3 hydrocarbons. So our 3 hydrocarbons, it will be alkanes, alkenes, and alkynes. So you are spoiled for choice. And then distinguish between, after you have done that, you identify any homologous series that is a hydrocarbon. For example, you said alkanes, or you said alkenes or alkynes. You will get that 1 mark. So you must write 1, not 3, because the keyword there is 1. So you can't say because you have 3 hydrocarbons there in the options, you have to write all of them. So who must choose for you? So you have to commit and say alkane, alkene, or alkyne. Any of those 3, you will be able to get your 1 mark. Hydrocarbons can either be saturated or unsaturated. Distinguish between saturated and unsaturated. So this is another way of saying define without telling you, because you are saying saturated, they have single, the S there, don't forget S for saturated is for single covalent bond between carbon atoms. And then the unsaturated, they have a double or triple covalent bonds between carbon atoms. So you are able to differentiate between them, and you get the mark there for differentiating them. I hope we are still moving together. When you see that table, remember FH-GMS. Again, our strategy, you look at it and say, I'm going to enjoy myself, FH-GMS. So what am I given here? I'm given the name. So they're starting from the end there, which is the name. Remember, we're saying F is for functional group. That is the first thing you must look for. Number 2, we're saying H is for homologous. H is for homologous series. H is for homologous series. H is for homologous series, and G is for general formula. M is for molecular formula. S is, so you are writing all of them. S is for structural formula. And then I for isomers, and then N for naming, the name of the molecule. So those are the things that you always be looking for. So if you look at the structure, they started here from the name, methyl ethanoate. You can even solve this problem going backward there to say, okay, let's start with the N is given, the name. Does it have isomers? Yes, it's an ester, and ester has isomers. Its isomers are carboxylic acid. So you know that, oh, we can ask you a question on the isomers. Yes, what will be the isomers? Does draw structural formula? Definitely, you will get that question that says draw structural formula of methyl ethanoate. So the structural formula, you know, methyl is a carbon, but it doesn't have 4 hydrogens, it has 3. Remember, we said for it to be methyl, it means one hydrogen has been removed. So because we removed one hydrogen, we are able to say that. Yeah, let me fix that as well. Thank you. Now we are able to say, okay, this we are having our hydrogens with no problem. We are able to go back to that to say we are having our hydrogens, and then we are able to move forward. Now we are saying our hydrogen is there. Our hydrogen is there, so that we get our structure moving with no problem. So as I take the pen there, then you are able now to get our hydrogen as well as we move forward. Then we just deal with that. Then we get our pen. Yes. So now, thank you very much. Now, as we move forward, we're able to say methyl is a CH3. So our methyl is a CH3. Then we move forward to methyl, which is a CH3. Then ethanoate, you know, O8, like O8. So you know we have O, and then we have the C double bond O. Ethanoate, ethan, you know, is 2 carbons. So there must be 2 carbons on the ethanoate. So you have 2 carbons there, and ensure, learners, that all the time you have 4 bonds around all these carbons that we're having. So you were able to draw the structural formula of methyl ethanoate. After structural formula, the question would be, what is the molecular formula? You just count the number of carbons. How many carbons? 1, 2, 3. So it's a C3. How many hydrogens? 3, 6. So it's C3H6. How many oxygens? 2. So C3H6O2. Definitely, you got it. Then you are able to move to general formula. What is the general formula for these structures? Esters is CnH2nO2. What is the homologous series? Is esters. Homologous series is esters. What is the functional group? You know is our ester bond that we draw the C double bond O bonded to the oxygen. So you just draw that. Remember to count the number of bonds around the carbon. There must be 4. So it's 1, 2, 3, 4. So you draw it like that. Oxygen is 2, so it's 1, 2. So you know that this is the structural formula. Because sometimes we're asking you to draw the structural formula of the functional group. You must be able to differentiate, because if the question says draw the structural formula of the functional group, you can't draw the structural formula of the organic molecule. You only draw that of the functional group, which is what I've done for you there in terms of your esters. So I hope that will help you moving forward. Definitely. Now we are saying look at number B as well. You can look at it. You will start and say, what is the functional group, OH? Remember I said structural formula, show all the bonds between oxygen and hydrogen. So now we're having the OH there, which makes it an alcohol. So the functional group is OH, which is the hydroxyl group. We call it OH, we call it hydroxyl hydroxyl group. OH is hydroxyl group. And then we are saying that OH is hydroxyl group. So that is the functional group is the OH, which is hydroxyl group. So you must know the name of the functional group. Number 2, homologous series. You're looking at the homologous series. This homologous series is an alcohol because of the OH hydroxyl group. It's an alcohol. What is the general formula? You are counting how many carbons. 1, 2. You always number from where we have the functional group, which is the OH. So this will be 1, 2, 3, 4. So that will be C4. How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. You can easily forget that we have another hydrogen attached to the hydrogen, the oxygen. We are having the hydrogen attached to the oxygen, so it's a hydrogen as well. So you must count it. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a C4H10O. And sometimes when we give you a molecular formula like this, it does confuse yourself. So it's good that you start by drawing the structure. It will give you the structural formula, will give you to say that this is an alcohol, because when an oxygen is going like that, you won't easily know that this is an alcohol. So be aware of that. So we have a C4H10O. So you are able to know that, okay, for us to put the OH here, we have removed one hydrogen. So this structure was supposed to be C4H9OH. But because it's 10 here, you must know that the H is from the alcohol, which is the OH1. So you are able to know that. I'm hoping you are following and you are understanding what you are doing. So that is the molecular formula. From there, we can be able to move as well to say, okay, structural formula were given. Does this alcohol have isomers? Yes, it can have a positional isomer, because we can simply move the OH to the right, to carbon number 2. I'll give you a minute or so to do number C, to apply the FH-GMS on this question, to say which one is the functional group, as I indicated there, which one is the homologous series, which one is the general formula, which one is the molecular formula, which one is the structural formula is given, which one is the isomer, does it have an isomer, what is the name of the structure, which are the questions that we'll be asking. So I'll just give you a minute or 2 minutes for you to be able to look at that question, then we can be able to finalize it with no difficulties. Thank you very much. Hoping you were able to apply our strategy of FH-GMS here. So as we conclude our lesson for the day, I want to look at your answers to say this is what we have done. Remember, you will look at the functional group. The functional group is what differentiates this structure from other structures. So that will be a C double bond H. So you see that, oh, that is a 4-mile group. So this must be an aldehyde. So you know that this is 4 carbons. So you are starting from here. You are saying functional group is a 4-mile. You have identified the functional group. If we say draw the structural formula of the functional group, you are able to draw it. And then the homologous series, we are saying these are aldehydes. The general formula for aldehydes, we said is CnH2nO, because there is only one oxygen there. The molecular formula for this structure, you count how many carbons do we have. You say 1, 2, 3, 4. So this is a C4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So it's a C4H8O. So that is your general formula, your molecular formula. Structural formula is given. Isomers, does it have any isomers? You remember, we said aldehydes and ketones, they are isomers. So a ketone will simply move the C double bond O to carbon number 2, then it will become a ketone. So you must know that that is a functional isomer. They have the same molecular formula, but different functional group. So you move, you say, what is the name of this structure? You number 1, 2, 3, 4. You know it's but. When it's 4 carbons, we said it's butan. Remember, for all the other structures, you write the whole name without E. Then you have the 4-mile group there at carbon number 1. So this is butanal, which is the name of the structure. So I hope you will go and apply this strategy as you revise your papers, as you prepare yourself, and you will enjoy organic molecules. And then this will bring us to the end of this session, hoping that you have enjoyed and you are going to apply our FH-GMS strategy so that you continue to understand everything. Have a good day. Thank you very much.